next thing we're going to look at is normal distributions and their z-scores. So first, what exactly is a z-score? A z-score is the number of standard deviations between a value x and the mean. It's how many standard deviations you are away from the mean. And the formula for z-score is going to be x, our data value, minus the mean divided by the standard deviation. So we're just trying to figure out exactly how far away from the mean we are in terms of our standard deviation. So let's look at some examples. We know that IQ has a normal distribution, and we know that the mean is 100 and standard deviation is 15. So what's the z-score of the IQ of 121? Well, z would be our IQ minus the mean divided by the standard deviation. So we have 21 over 15, which is 1.4. So here our z-score is 1.4. What about the z-score of an IQ of 93? Well, this time we have our data value, which is 93, minus the mean divided by the standard deviation, which is negative 7 over 15, which gives us negative 0.47. So it is possible for z-scores to be negative. All that tells us is that the number, our data value, is below the mean. And in addition, we typically round these to 2 decimal places. And later, whenever we talk about probabilities of normal distributions, it'll make it a little more evident why we only round to 2 decimal places. Let's look at one more of these before we move on. What's the z-score of a value of 100? Well, we have our data value minus the mean divided by the standard deviation is 0 over 15, which is just 0. And this is going to be true always. If we have a mean, the z-score for the mean is always 0 because it isn't away from the mean. Z-score is supposed to tell you how many standard deviations you are from the mean, and the mean is not any from itself. Now that we know how to move from a raw data value to a z-score, what about moving back? Well, if I have a z-score, I can multiply it by the standard deviation and add the mean, and that gives me back to the original data value. So just like I can move from a data value to a z-score, I can move from a z-score to a data value. Let's look at a couple of examples. For this one, I know that the average male height is 70 inches, and I know that standard deviation is 4 inches, and I want to know what height corresponds to a z-value of 1.93. Well, my formula says I take my z-value times my standard deviation, which is 4, and then I add the mean of 70. And when I do, I get 77.72 inches. Let's look at, female height has a mean of 65 inches, a standard deviation of 3.5, and the z-score that I'm looking at is negative 0.84. So I multiply my z-score times standard deviation plus the mean. When I do that, I get 62.06. So a z-score of negative 0.84 corresponds to a height of 62.06 inches.